Well, good morning. Welcome back to more geometry in my kitchen, the worst cooking show on YouTube. Exciting news today. Today you get to learn how to use another button on your calculator, but that's a little bit down the road. First, a couple new words. Well, this isn't a new word. You know, you've used this word before. Permutations and combinations. All right, permutations, combinations in math. Just talking about different ways you can group things together. And these are slightly different. In permutations, order matters. So in a permutation, if you have, this is one permutation, this is another permutation, because it's the same three letters, but they're in different order. So those are different permutations. Combinations, order doesn't matter, just matters if you're in the group or not. So combination, these are both the same combinations because it's both the same three letters. Order doesn't matter. For instance, if you were picking 3 cats out of a litter of 11 kittens, that would be a combination, because it doesn't matter if you pick this one first, this one second, that one third, or this one first, that one second, that one third. You've got the same 3 cats. Whereas if you're at Waffle House and you're trying to figure out how many different ways you can get your hash browns made, the order doesn't matter. So that's also a combination. Let me see, what's a good permutation? We'll get to permutations in a little while. In fact, here we go. We'll get to this right now. So, we're going to take a short trip to Utah. At least, we're going to look at their license plates. Now, this is according to the book. I have no idea if this is really true or not. Apparently, the license plates in Utah have 6 things on them. The first 3 are numbers, and then the last 3 are letters. And they do not use these 3 letters. Don't know why. Ask the state of Utah. Here's my question. How many different ways, how many different license plate combinations do we have if we have these rules? How do we figure that out? Ideas? Open ideas. All right, so here's how we're going to do this. Kind of, at least for now. This first thing here has to be a number. And it has to be a single digit. So like 10 is 2 numbers, that's a 1 and a 0. So how many choices do they have for this spot here? All right, well, they can put a 0, they can put a 1, they can put 2, a 3, a 4, a 5, a 6, a 7, 8, or a 9. So that is 10 options. Now, how many do they have here? Well, there's no restrictions. They can double, they can duplicate. It could be 1, 1 or whatever. So there's going to be 10 options again, and then 10 more options for that one. Now we get to the letters. They can put any letter here. There's 26 letters, but they don't use any of those 3. So there's 23 options for that one. And again, they can repeat. So, and then all you have to do is multiply. And if you do that math, I didn't do that math. Wow. Find out there's a lot of possible license plate combinations in the state of Utah. So there's 12,167,000 possible combinations state of Utah. So and that's the basic way you do this. Just write down. So let's see. Let's see if we can come up with another So now, that new button. You ever looked at your button and seen this? It might look like, it might also look like that. And then some of you have difficult calculators where you're going to have to actually go into math and find that thing. So now the reason this is because this is called factorial. But here's my question. Don't answer. If you know the answer, don't scream it out. So I don't want to ruin it for other people. What does this mean? I mean, yes, mathematically it's 6 factorial, but it doesn't mean 6. It's not just a super excited 6. This actually means take whatever number you start at and then multiply it times every number less than it. Technically you don't have to multiply by 1, but we'll do it just for there. And you get that, so what's that? 2, 6, 24, 120, 720. And these numbers get big pretty quickly. I think your calculator, well, I don't know now. Used to be calculators could only do up to 69 factorial, and then it got too big for the calculator. Some of them now can do more than that. Alright, so math almost always makes sense. There are a couple times when they just said, take our word for it, this has to be true. This, for no good mathematical reason, is defined to be equal to B1. And that's because we're going to use this in some formulas, and it has to be 1. If it can't be 0, it can't be undefined. So we need that. A couple weird things. This is a good math problem to have your parents see you working on. This looks like a really difficult problem. 100 factorial over 99 factorial. Remember, this is 100 times 99 times 98 times 97. That just said 69 is about the biggest most calculators should do. So your calculator probably can't even do this number. And it also can't do this number. But it's a little secret. You can do this in your head. So, what is 100 factorial equal to? Well, it's 100 times 99 times 98 times 97 times 96, da da da. 99 factorial is 99 times 98 times 97 and 96. If you look at this, all of that cancels with all of that, which means it just leaves that up there on top. So this is really just equal to 100. You won't see it that way very often, but you might see something like, I don't know, this. So 100 factorial over 97 factorial. Well, my marker's going away. Come on, back. Alright, so that's 100, 99, 98, and then from there down, that's going to cancel with the bottom, so it's just this. So it's still a big number, but it's not gigantic anymore. Alright, so why do we need that? We need that because there is a formula. Now, math always has to have formulas. So for permutations, suppose we want to know, we've got 7 books, and we want to arrange to know how many different ways we can arrange them in groups of 3. So we've got 3 slots on a bookshelf, and we've got 7 books to choose from to put it there. So it's different. So if we put, book 1 here, book 2 there, book 3 there, that's different than book 2 here, book 3 here, and book here. So these are 2 different things. And Now, there is mathematically, you could just figure it out. There's 7 choices for the first one, 6 for the next one. Yeah. But mathematically, the way we write that, permutations, it's a permutation, order matters. There are 7 objects, and we're taking them 3 at a time. So this is the official way that we write that down. And then mathematically, it's equal to this number, factorial, over this minus this, factorial. So this is 7, 6, 5, 4, 3, 2. We don't need the 1. All right, 7 minus 3 is 4, so this is 4 factorial. And we'll go ahead and put the 1. That cancels with that. So 6 times 5 is 30 times that. So there's 210 different ways to do that. So mathematically, that's written like this. That's not a C, that's an R. And that's written that way. So if you need to figure out any permutations, or they might start giving you this notation, well, they'll give you something like this, just plug it in here, figure it out. Now, combinations, a little bit more difficult. And not difficult, just it adds in some complexity. So, I mentioned before, kittens. You want to choose 3 kittens from a litter of 11 kittens. Now, combinations are written with a C instead of a P. There's 11 kittens. We're choosing 3 of them. Now, this time, order doesn't matter. If you choose Fluffy first or third, it doesn't matter. You've chosen her. So it's the same thing, whichever time you choose her. So order doesn't matter. So if you choose Fluffy, Spot, and Charles, one, you named your cat oddly, although I had a cat named Spot and a cat named Fred, not Fluffy. But if you choose Spot, Charles, and Fluffy, this is the same. These are the same things. It's the same. Doesn't matter. It's the same 3 cats. So we can't do it the same way where you just say there's 11 choices for the first one and then 10 for the second one. You have to actually take this into account. Now again, there's a formula. It's still that thing factorial on the top. But here's where the bottom gets different. It's this factorial times the difference of these two. So again, this is 11, 10, 9, 8, 7, da da da. This is 3, 2, 1. And then this is 8, 7, 6, 5. Alright, so all of that cancels with all of that. This is 6. That's a lot, 990. And then just do the division. Let me see how I get rid of it. See if I got the answer somewhere. It's 165. So there's still a lot, but nowhere near the same gigantic numbers as others. Oh, I could have looked there. Yeah. So we're going to do one more permutation problem, and then you'll be on your own. Sorry, this is longer than I meant it to be, but a lot of stuff to get in. Short amount of time. Alright, so we want to choose a president, a vice president, and a secretary for our club. I don't know, whatever club it is. And we have 5 people to choose from. Alright, so first question. Permutation or combination? Does order matter or does order not matter? So, if you got 5 people to choose from, and we're choosing specific offices, is this permutations or combinations? Permutations, combinations. Well, order matters because it matters if you're chosen for this position or this position. If you chose Elaine as president, Viola as vice president, and Bob as secretary, that's different than Bob as president, Viola, I don't remember their names, but it's so it matters. So this is permutations because order matters. So officially, it's written this way, which means we're going to do 5 factorial over 5 minus 3, so over 2 factorial, so that's 5, that's 4 times 3, and then that part cancels with that part down there. So it's just that, so 5 times 4, 20, and so there's 60 different ways you could choose that. To be honest, I don't use this formula for permutations very often. The combinations one you kind of have to, but permutations you don't. I just do this. We've got 3 slots. There's 5 people to choose for this one. Now once we've chosen one person, that means there's only 4 people left to choose for this one, and now there's only 3 people left to choose for that one, and then you just multiply. You get the same thing. Alright, so that's permutations, combinations, and the exclamation point on your calculator. If you don't have the exclamation point, you may have to go. You probably have a graphing calculator. You have a button that says math on it. Push math, and one of the options will be this, and then that's your factorial button. So do your 6 and then math, and then find fact, and that will do it for you. All right, that's it for today. Wow, sorry this was really long.